Hello, my name is Sandy Shagota. I am a teaching assistant at Faculty of Engineering, University of Rijeka, and this will be a short tutorial video for RobotStudio, ABB RobotStudio software package aimed at the tasks that our students here at the Introduction to Robotics and Basics of Robotics, as well as Industrial Robotics classes need to know to complete their basic tasks that they get during the classes. Just a note, as I said, this is a pretty base level tutorial. The RobotStudio itself is a quite expensive software package with a lot of options. We're just going to cover the basics. First thing first, to make sure your RobotStudio is activated, at this starting screen to the left you will see options. Click on them, wait for a minute for them to start up, and then select licensing. You'll have two options here: My Licenses and Activation Wizard. Go to Activation Wizard and choose the type of license that you have. Again, if you are our student, you need to go to, at this point in time, to network licenses, and then I want to specify network license server or managed server licenses. It's possible that in the future you may receive a different license type. If that's the case, if you are unsure, you can do this. Just contact me or whoever's in charge of the class at that time and ask them to give you this information. But for now, select to specify network license and enter the URL you were given. This year it's robotstudio.ritech.hr. Once you added this, it should show that the server is online. Click Finish and go to My Licenses. Here it should show that all the licenses you have are the network type and they are valid. If this didn't work, try activating again or try restarting the ABB RobotStudio. If this doesn't fix it, contact whoever is in charge of the class. If everything is fine, just click OK and come here to starting a new project. Besides the project, you can create an empty station and manually add whatever you need in there. A rapid module file, which is programming language used by ABB robots, and a controller configuration file. To avoid adding all of this, just go to the project and you will name it something. I will just name it Robot Base Demo. In addition to that, you have a path here. Now, just a warning, I will show you that if I come here, this is going to throw an error. Why? Because in Croatia we have diacritics here, so if you are one of our Croatian students, not an Erasmus student, or if you're an Erasmus student from the location that uses special characters, please make sure that your path doesn't have any special characters in it. Select the include robot and virtual controller. Now, for selecting the robot, it depends. Maybe you were given a task to use a specific robot, or maybe it wasn't specified. Then you can choose whichever robot you want, whichever you like. In case you are working for a final project, or you're working on a project that's planned to be realized in reality, please select the RB120 robot, because that's the robot we have available to students in our laboratory at this time. Under the whichever robot you select, you may have two options here, or just one. One is Robotware, which is the simulated firmware of the robot. Make sure this is the latest version available to you if there are more than one. and a controller of the robot. If there are multiple ones, just leave it as the default one that was given to you here. I will select the 120, which we use with students for projects. Robot, make sure the robotware is the latest here, and just click create. Now this may take a minute, so while that's going on, I will just introduce you to the interface. This in the middle is your station, your empty space where your robot will exist, and you will program it. Okay. Up here you have your commands, various types for whether you're doing modeling or simulating. You want to tune the controller, whatever you want to do. To the left, it's layout and paths and targets. Layout will just show you your robot layout. I'm going to show you that in a second. And paths and targets, I'm going to show you your paths. We're also going to go through that as an example. Here, some robots may have different versions. Again, if you're just picking a robot at random, pick one at random here. If you are not picking a robot at random, if you are working with 120 in our lab, then select the first one. Okay, and you'll see that once the robot has been added, the loading that was going on in here has finished. You will have a few options here that matter to you. One is the selection level that allows you to select entire objects or just points, whatever you need, especially when you're modeling, as is the snap to tune whether your selection is going to be snapping anywhere. And then you will have some information about the station. You'll have different types of movements. I have went through this in the class. If you attended it, if not, you have the presentation. It's really simple, just different types of how the robot is capable of moving between 2 points, and you have the speed and the zone. The speed is pretty self-explanatory. The zone is something I'm going to demonstrate you once we create the path. You have a tool. Obviously you can add a number of different tools to the robot. All robots in reality is going to have some sort of an end effector that you can add to them, but in reality you don't necessarily need to have one for just simulating the robot movement. If you do want to add one, you have, for example, under importable, you have a smart gripper. You have different options. For example, you have this pen that you can add, that was added here, and it was added here in the to the left in this tree, right? Of course, the end effector is located here at the origin when it is originally added. That's not the most practical. You want to attach it to something, so right click on it and select where you want to attach it. You can attach it to individual points, but you can just attach it to the robot directly, and it's going to go to the final link. Now when you move the robot, it's going to move the pen as well. Let's just cover the navigation element of the robot, you within this station. So left click will allow you to select stuff. Zooming in and out is done with the scroll wheel. You can either scroll up or down, or you can press the scroll wheel and move your mouse. If you want to pan the view around, it will be Control plus left click. And if you want to rotate, it's going to be Control Shift plus left click. Right click is just for options. Okay, now moving the robot. There are multiple different ways you can move the robot. You can specify the positions of joints. You can program it using Rapid, which I'm going to briefly show later on. But the simplest that you need for this task is just manually adjusting the position of the robot, because if, at least currently, the task you have is, for example, writing some letters with this pen. You don't need the high precision for this, so I'm just going to show you how to move the robot freehand without being too precise about it. Of course, if you have a more precise task, there are ways to move the robot more precisely. The first thing that we're going to do, for example, jog, is select one of the joints of the robot, this one for example, and going to this upper ribbon, we have this freehand option. We are interested in these first three options. We will use world as reference and select jog joint. Jog joint allows you to move a single joint without affecting the rest of the robot. So all the joints of the robot, all the links are not moved, except this joint and whatever is attached to it. Then we have a rotation. You'll see that it's very helpful. It goes to the end of the tool, and with this you can rotate using Euler angles, so pitch, yaw, and roll. You can notice that this movement moves the entire robot to achieve your movement. This point at the top of the end effector is fixed, and you are rotating around it. Okay. And finally you have the XYZ movement, where you can just move it in the XYZ axis. So those are the three ways that you can move your robot. So again, XYZ movement, rotation, and joint jogging. So now you learned how to add a robot, how to move it. Let's move it automatically. So select your robot and add a path to it here in the upper ribbon. So just click here on the path. You will see that you have collision-free path, which will automatically avoid collisions with objects. You have an auto path, so if, for example, you have a geometry here like a cube or a table of some sort, and you wanna follow a part of that geometry because you're simulating welding, or for example painting an object, you can use that. But for the purposes of this demonstration, we're going to use empty path. Now you will see that we have moved from here to the left from the layout to paths and targets, and we have under paths and procedures an empty path here. If I now go and do the teach instruction path, the path is no longer empty, it has a single instruction here. Now I can move a robot, so I'm going to select this, jog joint, and let's say move this joint here. Now you see that you have this coordinate system here. That was the initial target we had before. I can teach another instruction, and it's going to move to add a different target. Now we have one target here, and we have this yellow path in between. I can now move the robot around some more. For example, from here I might move it a bit back. And this is something that you can note. If you were in class when I showed this demonstration, I talked about singularities. Singularities happen when the robot's configuration dictates that it moves infinitely quickly, depending on its configuration, the movement, and the speed of the movement. This can happen. So you can see that this robot will flip up immediately. That's an error in the programming, in the configuration, which you must avoid. How to avoid them? Well, be careful how you're moving your robot. They can be avoided mathematically, but for at the level that we are covering in this class, it's best to just avoid them manually. Just be careful of your configuration. If it happens, if this error or another error happens to you once you have created the path, once you go to run it, it says like, oh, the singularity was detected, or the position of the robot, for example, like here, is out of reach because it's going to crash into itself, or it's simply in a position where it's too weak to actually reach. You can click on the target and just modify the instruction to change, for example, the speed, or the zone speed can help you. If you go very, very slowly, it can avoid some, not real full singularities, but some singularities, and you can just generally modify and edit each individual instructions where they're located, or simply delete them and re-add them. My advice is to, when you create a part of the path, just run it to make sure everything is fine. So if I, for example, go here, a bit forward, I can add another instruction. And now I can try running this by clicking on the path, right-clicking on the path and going move along path. We see that we have some sort of an error. Yeah, we are close to singularity. We can see that we messed something up. We got to the position where we're very, very near to singularity. So we can return to this original target here, which was very close to our original option. I'm going to delete these two targets. Go here, you can see that these targets here still exist. You can just go to the world object here and delete them if they are annoying you. You don't have to, you can just have a bunch of targets existing around. So yeah, we have accidentally found a singularity. It's not a problem. We have deleted that. We're going to be more careful. For example, I'm going to go here instead. Teach instruction. And let's say move it here. And teach that instruction instead. Then move along the path, and now that the path is reachable, that I have corrected it, I can move it. It's going to go to the start immediately. This isn't the best way to see this, maybe like this, and it's going to go here. Yeah, so great. Let's now try moving this a bit down. Teach instruction. Great. And down a bit more. Let's see if this path worked. Move along path. Yes, it works. Okay, great. Now, 2 points to address are the speed and the zone. What do I mean by the speed and the zone? well, the speed is obviously the speed of the robot. In RobotStudio it's not defined. It's not fixed, it's not going to tell you, oh, this is moving at a certain speed. It just has speeds from 5 to 7,000. The higher the speed, the higher the actual speed of the robot, but you don't get a constant speed. Why? Because robot speed can change depending on their position. So let's say I'm not happy with how fast certain parts of this movement are. Maybe I'm worried about the robot crashing into something. I can actually change that. I can click here. I can modify instruction and select the speed to be much slower. Let's go with 100. Now this initial part of the movement should be much faster. Let's try it. Much slower, pardon me. Okay, yeah. There we go. Let's see that again. Yeah, so just to note, when you select the target, it addresses the speed before the target. Okay. So I'm changing now. If I modify this in this position, it's going to affect this movement here. So let's set that to 80, for example. Move along the path. And you can see that the initial movement and this movement is slower, and then it speeds up. Okay, so what's if with this zone where, well, for example, you can see that this is the point we told the robot to go to, but the path doesn't touch this point. Let me show you. If I move it here, that's target 30. I'm just going to slow this down to, let's say, V150, and the next one to V150. Just to slow this passage through so you can see it a bit better. Now if I move it, once it gets here, you can see that the robot follows this path. We can go in slower to see it better. You can see that I can select and change different instructions individually by selecting multiple of them, and just not individually at multiple at the same time. So it's going to go here, it's going to move, and it's going to slow down here from this target to this target where I modified the position. And you can see that the robot is going here and is going to follow exactly along this path. It doesn't touch this point or this point. Now this is fine. Let's say I'm trying to move a screw from here to here, right? From this target to this target here. I'm picking up a screw from a holder here and moving it to a hole here. I don't care about passing this point, right? I might want to go directly. Maybe that's not possible because there's something here, an object that's preventing me from doing that. I want to go around, or I want to approach this object from the top. It doesn't matter. Obviously I need to touch this point because my end effector is going to activate here, and I need to touch this point because that's where my end effector is going to do something. But I don't need to reach this point, I just need to go near it. So these points are called flyby points. And whether a point is a flyby or you need to be precisely in it, it's controlled by a zone. So if I go to this target and select, right click, go modify instruction zone, you can see that I can go from fine to zone 200. So if I go to, for example, 200, it doesn't change much. Let's say I go to modify instruction zone fine. It does go precisely into that point. So I want to do the same thing for this point, for this target 20, so I can right click, modify zone, fine. I can go Z0, you can see that Z0 is essentially fine. There might be a small curve here. It doesn't matter, and for this flyby point, I can control it. So I can go here, and I can use zone. For example, if I want to reach that point exactly, again, I can go fine, and I can change that. The more I increase it, the more you'll see this curve and the distance increase. Yeah, so you can tune the overall positions here using the speed and the zone for your entire simulation, and then manually tune individual points if necessary. This is one of the reasons why you don't specify the speed as meters per second, because obviously your robot will need to slow down to do this movement precisely. This type of movement is much faster because the robot need to slow down as much to precisely reach this point. So let's try moving this along the path now. It goes back to the start, it moves it, it precisely reaches this point. I forgot about making this faster, so we're going to wait a minute. It's going to follow this. Obviously, we're at this point. It's going to go following along this path, and it will precisely reach this point where we said that the zoning of this target is fine, and then it's going to speed up and go here to the end. Great, so this is essentially all that you need to cover your the task that you have. You will need to write some sort of letters or something, play around with the robot. The basic of the task is just to let you familiarize yourself with the robot a bit, about how to move it in space, how it moves, and stuff like that. It's not, the point isn't to go into great detail, but one thing that can be useful to you is just a rapid programming language, so I'm going to show you that. So if up here I have kept this home, but we can observe we have modeling, so we can add parts, we can add cables and physical joints and floors, etc., because the robot can now actually go through the floor if we are so inclined here, because it's not a physics floor, right? So you may, depending on your, oh, it won't let me do it like this, I have to jog it. Oh, yeah, so the robot can go through this floor because it's not a physical floor. And you can do a lot of modeling. I'm going to, if you're doing relatively simple modeling, yes, you can do it in RobotStudio. It's gotten much better over the last couple of iterations, but my advice is to fire up SolidWorks, create whatever you need, and then import the geometry using the STL or step files. I'm not sure which. There are various different types supported. You can play simulations from here if you have a simulation. Our robot isn't ready for it because we don't have any code for it, but we can add code for it. So we can right click on the path here, and we can select this option, synchronize to Rapier. And it's going to tell us, well, what do you want to select? Do you want to have the calibration date and everything? I advise just selecting everything if you aren't sure what you're doing. Great, we will see that So information is here, the model has been edited. Now we can go here and select rapid. Beyond that, you have the only thing I didn't explain is controller. You can simulate, for example, the flex pendant, which is the controller, which is the input device for the robot here, because you can program it. You can get an error, and you can basically simulate that here. I don't have the software installed for it, so that's why it's not working. You can analyze signals. This is very useful because you can tell your robot to track its power usage and its torque for some robots and stuff like that here. Here very simply, and then export that and analyze it. So for example, if you want to, the theme of my doctoral dissertation is lowering the energy use of robots like this. I can just simulate various paths here and check their energy use. And finally we have the rapid here, which is for controlling the rapid code. I'm just going to briefly go over it for you. So here to the left, once you go to the rapid, you will have this option. You will have the configuration, event log, IO system. Select the rapid, select this T-Rob1, which is your robot, and you will have different modules. You can click on them, double click on them, and it's going to open it. This is the calibration data for your tool, for your pen. We have a module, and you will have some system modules that just define the tool data, work object data, load data, etc., and some information for the user registers. These aren't stuff that you're going to that commonly use. You will probably mostly use these modules. So for example, in module 1, I'm going to briefly explain to you what happens and what are you doing here. So you have these variables list called rob targets. These are the targets that you can see here, just encoded into the code. You have 1, 2, 3, 4 elements to it. Now let me just see if it's going to let me show you. No, it won't. Okay, but I'll show you just manually. This is going to be the world object data. You don't necessarily need this is going to get filled out automatically when you add the target. Same here for the speeds and the zones, and what matters to you most is going to be these two triplets that are basically defining your position and your orientation of the robot in this target. These are the variables that are defined at the start, and then you have the start of model and its name. You have the variables here, the constants that are defined, and then you will have your main subroutine like you would have in C. You have prods and prods. You can add the code here, and you have sub procedures. For example, outside of your main, you have this path 10, and you will have a simple move L. It's a linear movement. I have described a different. Oh, there actually is some help here. Yeah. So you can see that you have the position. You can hover your mouse over the variable type, and it is going to show you some information. For example, move well is going to tell you for the move well and different types of movements like circular movement. I have also went over different types of movements in the presentation in the class, so I won't repeat myself here needlessly. This is already a pretty long video. You will just select the target which you have defined up here, or either coded it or selected it from the station. The speed, the zoning, the tool you're using, and which work object you're using. So for example, let's say I want to speed up everything here. I want to just speed everything up. Sorry, there's one thing that I forgot. So this procedure is added outside because I have added it as a path. I can just add this code here to actually run it. So the code to run needs to be in the main. You can obviously just call this procedure. You don't need to copy paste the code. So now I can use the simulation, and that code should actually run, right? So because it's running the main. So here is going to move here, here, here. So let's say, why is this useful for the modification? Well, because I can stop the simulation, right? Edit this. Let's say I want to just let me see if I can add just like this. I don't know if that's going to work. Let's try it. No, there's an error. So instead of having this path and calling it, I'm just going to manually add it. You can run different subroutines if you want to, but the simplest way is to have it just in your code. And yeah, here's the simulation. We're running it. Let's say I want to change this from this original to this modified version. Let's say I want it much faster. I can just modify this all to be 1000. Or I can go, maybe you noticed here I have something called Vmax. We can use Vmax. So we're going to move the robot at the max possible speed. And we're going to use all these at 200. So it's going to be a maximally flyby points, except one. Okay. So let's see how does that look. We can see that the robot is much faster, and the reason why I left this one point as a fine, you can see that the robot actually slows down to reach it properly. And that's pretty much it. We can see that of course this path doesn't measure this path anymore because we have added additional points and modified it within Rapid. So that's also an option. And this is more for you as a student to let you know, hey, this Rapid code exists. You can edit it. You can use for loops. You can use conditionals. You can read signals. You can generate signals and a lot of stuff. But that's beyond the scope of this tutorial. It's mostly just to let you know that, hey, this code exists, and you can actually manually modify it or manually write it and import it. And that would pretty much be it for the purpose of this class. As I said at the beginning, the RobotStudio is a pretty capable software package with a lot of features, so if you have any further need for further simulations, if one of our students contact me, I will gladly help you, but there are rather extensive forums, and there is a rather extensive documentation for using both RobotStudio and Rapid programming language that can be found at the manufacturers at the ABB website. And as far as I remember, they are available to you for free, so you can just download them and check them out. And that will be pretty much everything for this tutorial here. Thank you very much, and yeah, I hope this was helpful to you. Thank you.